There is a place in Wyoming where the ground bleeds color, where pools of water reach 189 degrees Fahrenheit, hot enough to scald you in seconds. Where the water is as acidic as battery acid in some places, pitch black and boiling in others. Every instinct you have tells you nothing should be alive here. You'd be wrong. Lurking in these impossible pools are creatures so ancient, so strange, so fundamentally different from anything we call normal life that scientists have spent decades trying to understand where they came from. And the answer they keep landing on? We genuinely don't know. What we do know is this: whatever is living in Yellowstone's pools might be our best window into one of the biggest questions humanity has ever asked. Is there life somewhere else? To understand what's living in Yellowstone, you first have to understand the world they live in. Yellowstone sits on top of one of the most powerful volcanic systems on Earth. Beneath your feet, magma superheats groundwater and forces it up through cracks in the crust. The result? More than 10,000 hydrothermal features. Geysers, fumaroles, mud pots, and hot springs, more than anywhere else on the planet. Grand Prismatic Spring is the most famous. It's roughly the size of a football field. The water at its center sits at about 189 degrees Fahrenheit, and those stunning rings of color, the orange, the yellow, the rust red, those aren't minerals. Those are alive. They're enormous mats of microorganisms clinging to the edges of something that should kill them. The center is too hot even for them, so they colonize the gradient, the zones where temperature drops just enough for survival. Different species at different temperatures, each one thriving in a narrow band of heat that would cook anything else. And that's just the beginning of what makes them strange. The organisms living in Yellowstone's hot springs fall largely into two categories: bacteria and archaea. You've heard of bacteria. Archaea are different. They're so genetically distinct from bacteria and from us that scientists had to create an entirely new domain of life just to classify them in 1977. Archaea were discovered largely because of Yellowstone. Here's what makes these organisms genuinely baffling. Most life as we know it needs a few things: moderate temperatures, liquid water, organic compounds to consume, and a source of energy, usually sunlight or other living organisms. These extremophiles, as scientists call them, have thrown out that rulebook entirely. Some of them thrive at temperatures above 176 degrees Fahrenheit, close to boiling. They're called hyperthermophiles. Their proteins, which would unravel and die in you or me at those temperatures, are specially constructed to stabilize in heat. Not just survive it, they actually function better the hotter things get. Others live in water with a pH close to 0. To put that in context, your stomach acid sits around pH 2. Some of these microbes live in pH 0 pools. They shouldn't have any working chemistry left. And perhaps most astonishing, some of them don't eat anything that came from the sun at all. They're called chemolithotrophs. They eat rocks. Literally. They extract energy from chemical reactions in inorganic minerals. Hydrogen sulfide, iron compounds, ammonia. No sunlight, no organic matter, no food chain. They are their own food chain, powered entirely by the chemistry of the volcanic earth beneath them. Life, rethinking itself from scratch. Here's where it gets genuinely mysterious. When scientists first began studying these organisms in the 1960s, largely thanks to a microbiologist named Thomas Brock who had the audacity to just stick collection tubes into boiling pools, they assumed these were recent adaptations, life that learned to tolerate extreme conditions over time. But the genetic record tells a different story. Archaea are ancient. Not old in the fossil record ancient, ancient as in potentially among the first forms of life on Earth. Some researchers believe they emerged during the Hadean Eon, more than 4 billion years ago, when Earth itself was a volcanic hellscape of boiling oceans, asteroid bombardment, and toxic atmosphere. An environment that looked, by the way, almost exactly like what you see at Yellowstone today. Which raises the question that nobody can fully answer. Did these organisms adapt to extreme environments over time? Or did extreme environments produce the first life, and everything else, Every plant and animal and person on Earth is the adaptation. Did life begin in hell? There are competing theories and no consensus. Some scientists point to alkaline hydrothermal vents on the ocean floor as life's origin point. Others argue it was environments exactly like Yellowstone's pools. Both sides agree on one thing. The microbes in Yellowstone are living windows into conditions that may have birthed the very first living cells on this planet. We're not just looking at life. We might be looking at where life came from. Because when you strip away the geography and look at the conditions these organisms can survive, extreme heat, extreme acidity, no sunlight, no organic food, toxic chemistry, you start to realize something uncomfortable. Those are not Earth conditions. Those are space conditions. Mars, for example, once had liquid water. Beneath its surface today, there may still be hydrothermal systems driven by volcanic heat. If life ever emerged on Mars, the model that makes the most sense is Yellowstone. Chemolithotrophic microbes eating rocks, thriving in heat, indifferent to sunlight. Then there's Europa, one of Jupiter's moons, which is covered in a thick shell of ice, beneath which scientists believe sits a vast, warm, liquid ocean, heated by tidal forces from Jupiter's gravity. No sunlight penetrates that ocean, but hydrothermal vents? Almost certainly. And we've learned from Earth's deep ocean vents that life thrives there without a single photon of light. And Enceladus, a moon of Saturn, is actively venting water vapor and organic molecules into space from beneath its icy surface. Cassini flew through those plumes and detected hydrogen, carbon dioxide, and methane, exactly the chemical signature you'd expect from hydrothermal systems like the ones supporting Yellowstone's microbes. We haven't found alien life yet, but if we do, the scientists who've spent their careers in Yellowstone's boiling pools believe they'll recognize it, because they've already seen what life looks like when it decides to play by completely different rules. The alien life we've been imagining for decades might not be little green men. It might look a lot more like a microscopic organism, invisible to the naked eye, eating sulfur in a boiling pool in Wyoming. The pools of Yellowstone are still giving up their secrets. Every year, scientists find new species that weren't in the textbooks, new chemistries, new survival strategies, new genetic sequences that don't match anything else in the database. Thomas Brock's original hot spring isolate, a bacteria he found in 1966 in a pool called Mushroom Spring, eventually led to a breakthrough called PCR, the polymerase chain reaction. It's the technology behind every COVID test, every DNA forensic kit, every genetic study ever run. It came from a microbe in a boiling pool that nobody thought mattered. We don't know how many more breakthroughs are still sitting in those pools, unsampled, unread. We don't know exactly how old these organisms are, or whether life on other worlds could mirror them, or whether the volcanic cradle that made them might have made us too. What we do know is this: the next time someone tells you that the universe is too harsh, too extreme, too inhospitable for life to exist out there, show them a photo of Grand Prismatic Spring. Life doesn't wait for the right conditions. Life makes the right conditions its home. If you enjoyed this video, please like, share, and subscribe. This has been National Park Mysteries.